Let's say, for example, that we have a bottle of liquid water that is half full and we have a cork on top of it so nothing can escape. Now remember that when particles are liquid, they are rigid and close together, but at the same time they move and they flow past each other. Now let's say one of the particles near the surface gets bumped by another particle particularly hard. What will happen is that particle will actually bump out of the water and evaporate into a gas, as you can see by these green particles. Now let's say this happens to a couple particles and we have enough gas particles on top of the liquid. What these liquids will do is that they will exert a pressure on the liquid particles below. This pressure exerted by these evaporated liquid particles is known as vapor pressure. But let's remember that gas particles move even faster than liquid particles. And some of them will say, let's say, for example, this one bounces off the container and bounces back into the liquid. It'll actually return back into a liquid particle. What happens is that some liquid particles become gases and some gas particles return to liquids. This is known as a dynamic equilibrium. This is because there's constant motion, but there's the same ratio of liquid particles to gas particles. Some factors regarding vapor pressure that you might need to know for a class. The first is surface area. So let's say instead of this bottle, I want to increase the surface area and the amount of water molecules reaching the surface of the water. So instead of this bottle, I got a pan where there are more exposed water molecules. So what will happen is that some of the more water molecules will actually evaporate and become gas particles. As you can see here, there are more gas particles than in here. However, the vapor pressure remains the same as the area increased. So let's say in this bottle, where there is a low surface area, there is a vapor pressure of 24 torrs. What will happen is in this pot with the same amount of liquid, there will be the same vapor pressure of 24 torrs. So all you need to remember is that as you increase surface area, vapor pressure does not change. Another factor regarding vapor pressure that you should know is temperature. So what I have is the same bottle. One is cold under an ice cube and another is warm under a fire. So what will happen is in this cold bottle, remember that when objects are cold, they have less kinetic energy and they have less motion and they don't really want to move as much. As a result, there will be less gas molecules. So we can say that vapor pressure is low in a cold temperature. Now we have the same bottle, but instead of an ice cube, we have a fire. Remember that if you increase heat, add kinetic energy, molecules will begin to move faster and more water molecules will escape into gas. As a result, there will be more gas particles and vapor pressure will increase. So remember that temperature is different than surface area. There's actually, if you change the temperature, it will actually change the vapor pressure. In cold temperatures, there's less vapor pressure, and in warm and hot temperatures, there's higher vapor pressure. Third and final factor that affects vapor pressure is intermolecular forces. You remember intermolecular forces, or IMFs, are the forces that keep molecules of similar types together. We have strong types of intermolecular forces such as hydrogen bonds, and weak types of intermolecular forces such as dipole-dipole bonds and London dispersion forces. Now, let's say we have a liquid with high intermolecular forces. This liquid has a lot of hydrogen bonds. These include molecules with hydrogens attached to fluorines, oxygens, and nitrogens. As a result, the molecules of that liquid really wish to stay together, and less of them want to shoot out from the liquid and become gases. As a result, there are less gas particles, and vapor pressure is once again low. Now let's go to this bottle with weak intermolecular forces. Let's say there are a lot of dipole-dipole bonds, London dispersion forces, but really no ionic bonds or hydrogen bonds. In this case, molecules are less bound together. As a result, they are more likely to fly out and become gases. In this instance, vapor pressure is high. This is because more gases are able to escape and exert pressure on the liquid. So just remember, intermolecular forces, if you have high intermolecular forces, low vapor pressure. If you have low intermolecular forces, high vapor pressure.